Awesome. Thank you. Whoa. Is this too loud? I can hear myself at least. That's good. Thank you for coming. Let's see what goes. Fit my slides. That should do it. Okay. So if there. So I think we've all seen this, or we've all been in this situation ourselves. I have at least a lot of times. It's a really frustrating situation, and it says there's paper jam, and you look in it, and you open it up, and there is no paper jam. But what I really think is going on is actually that, I mean, if you were a piece of paper in the printer stock there all day, you wanted to have a little bit of relaxed time and do some jamming, right? So maybe it's not all that bad. So looking at printer errors, I came across this conservationist working at a library, and I'm sorry I couldn't figure out, I didn't even know if it's a woman or a man, but I couldn't figure out the name of the person. But the person found this really interesting 18th century newspaper with something I think we've all seen. On the back of this page we're seeing here, this is from a newspaper called Purple, I think. On the back it's a smooth printing, everything is fine. But on the front side of the paper, we have this weird crease, and when you pull it, you have a printing error because the piece of paper was folded in a way when it went through the printing press in the 1800s. So printing errors are nothing new. This is also, I think, one of my favorites. It makes absolutely no sense. Researching this, I found that maybe it makes more sense to you guys than it does to me, because apparently letter is a size of paper that you use in America, but in Europe we like these like nice, even things that can divide up into even smaller parts. So we have a different kind of lettering or paper size system called A4, A5, A6. But still, I think this was one of my first times I saw this error. It was on an HP LaserJet, and actually the PC load letter comes from the HP series. And the reason why it says PC is basically just means paper cassette. So paper cassette load letter. It just says you're trying to print something to the printer, and there is like not a letter. There's like an A4 piece of paper in the printer, but there is not a letter piece of paper. So please load some letter because I can't print this thing you're sending to me. And the reason why it says PC is because if we go back to early printers, you didn't have a nice big display as we saw before. You had like two digits on the left that was basically just a status code, like you have an HTTP status code or whatever. And 00 means everything is okay, I'm ready to accept print jobs. But you could have PC in there. So that carried over to the larger displays when we had those. So what got me into all this printing stuff? To understand that, I will just tell you a little story. So about a year ago, I was fiddling around with, I have a lot of Apple devices, and one of them is an Apple TV. And you could send stuff to it, and I also have an Airport Express. You could send music to that, and you could play music. And it was all like fine, but I wanted to like be able to like tweak the volume a little bit more than you normally would be able to do. So I was thinking, could you like have a proxy in between that could do something, but then you needed to like send the audio to that proxy, and that would have to send it to the actual Airport Express to play the music. And I found there was something called Airfoil that could do this, but you had to pay money. Otherwise, after like, I think it's like 10 minutes, it will start to play static instead of the music if you haven't paid the bills. So I was looking online, and I found like a lot of open source projects that was doing this, but all of them, they were more like, I want to be a client and I want to talk to an Airport Express on Apple TV. And I was like the other way around, but I want to be an Apple TV. I want to be an Airport Express. Is there a way to do that? So I realized that somebody already did a little bit of research into the protocol behind it, but nobody actually implemented a proper server. So I went ahead and thought, okay, I could do that, which was my talk at JSConf EU this year about how to be an Apple TV. But during this process, I figured out that the way that Apple TV works and the way that you just pull up your phone and you are on YouTube and you want to just show what you have on your phone on your TV, it just magically pops up and says Apple TV, living room, or whatever you name it. And it's like, how does that work? And I figured out it was something called Bonjour. And then I researched that, and I figured out that Bonjour is basically just a standard. It's basically just the branding of a standard. Bonjour is a name that Apple decided, but the standard is called JSConf. And JSConf is an RFC, or it's a lot of RFCs on the internet. So it's an open standard. Everybody can take a look at it. And it's basically, behind the scenes, it's basically just doing what's called multicast DNS. So when you have a local network, you broadcast packets to the network saying, hey, here I am, and I have these capabilities, and my name is called Apple TV Living Room, and stuff like that. So there's a whole standard for that, and it's called MDNS SD, or the SD is for service discovery. And I found that out, and I was like, oh, that's interesting. And on NPM, there is a module called MDNS, which basically is just a shallow binding on top of Apple's binaries for doing MDNS stuff, like advertising a service on the local network. Which means that you have to compile it. It doesn't compile on all systems and stuff. So I thought, okay, maybe we can do this in native JavaScript or in Node, where I'm a Node developer. And a friend of mine, Matthias, or Macintosh on Twitter and GitHub, he already wrote a very, very low-level MDNS module that basically just allows you to send and receive packages. But it's nothing more than that. Where the MDNS SD standard, the service discovery standard that lets you like advertise a service on the network, specifically says there's like 3 DNS records that you need to use to do this. You need to have a TXT record. TXT record is kind of like a hold-all record. It's just like a blob of data. And it can like hold a lot of information about like the capabilities of your Apple TV and stuff like that. Then you need a SRV record, which is basically just a fancy form of a record. The a record is the one you have for your domain. It says, I have mydomain.com, and it points to this IP address. But then SRV record does the same thing, except also it specifies a port number. So it's actually really, really, really nice. So you don't have to rely on a default port number like port 80 for HTTP. You can have a service running on any port. And then you have, the final one was a PTR record, was basically just a way to point to the right SRV record to use. So you have the PTR record says, I have an Apple TV, and then it points to this SRV record that has the name of the Apple TV that you want. You can redefine that name anytime you want to be called living room or whatever. So I was looking into this, and I made a module called JSConf, which basically does this. And while I was doing that, I took a look at all the different kind of services you could advertise on a network. And this is part of a huge, huge, huge document of different services you can advertise on a network. Some of them are proprietary. It's all managed by IANA, Internet Assigned Name and Numbers. There's the same guys who also does I think they do the .com and .net and all that stuff as well. And there was one thing in particular that struck me was like IPP. It's like, what's that? Internet Printing Protocol. I never heard about that before. And as was thinking, okay, this is service discovery. This is JSConf. The whole premise about JSConf is that it's plug and play. It's like no drivers. It just works. You don't even have to do configuration. You don't have to enter anything into anything. You just click and it just works. So it's like, how can you have a printer that you click and it just works? That seems a little strange to me because normally I would think you would need to have drivers and stuff. I did a little research into, I tried basically just to use my JSConf module and say, okay, I'm an IPP service and I'm on your network and I'm on port 3000 on my local host. And then I went into system preferences and said, okay, let's try to add a printer. And lo and behold, there was a printer called, I gave it a name, I think I called it Node.js or something. And it was like a printer called Node.js. I was like, well, this is interesting. What happens if I install it? So I clicked install, and it just went through, and everything was just working, like it got installed. But if you heard what I just said before, that I just basically advertised the service. I didn't actually set up a server listening on port 3000. I just advertised the service. I was like, okay, probably I can't print to it then. But just to check, I spun up a TCP server on port 3000 and was listening for a connection, and then I tried to print to it and see what happened. And there was a blob coming in, so something happening. So something was happening, but the print job didn't go through. It just said error. The print job just said error. But I got some data, and I was looking at the data. I was like, wait a second. I could like see it was ASCII. I could look on the hex, and it was ASCII. And it was like POST/HTTP. And I decoded it, and it looked something like this. I was like, that's just HTTP. This is easy. So I better check out this whole IPP thing. So I went and looked. There is also an RFC, so you can go and look at the standard. I've become pretty good at reading RFC, by the way. It's a pretty bad skill to have, maybe, I don't know. So I finally realized what this IPP was. So basically, IPP is actually a binary protocol, but it's using HTTP as a transport layer. So the operation layer is binary, but the transport layer is HTTP. So we all speak HTTP, and it's the way it works is it's just using post requests all the time. It's the only method it uses. All this post request, usually just to slash, but you can have like different printers on the same port, and they would have a different name, a different path. But if you just have one printer, you would just have it on the slash. And the reason why it uses the slash is because when I broadcasted the service on the local network, I just said I didn't say anything, so it just assumed slash. I didn't give it a path. And you can see it's the user agent this is from OS 10, and the user agent is COPS, which is I can't remember what the C is, but Unix printing service. So what? Common Unix printing service, which is a pretty, I found out, like pretty well established library on Linux and Unix and OS 10. So after the headers, these are the headers. There's nothing more than this. After the headers, the body comes. The body is this binary blob of operational protocol. And if you look at the hex of that, it always starts with 2 bytes, which is the version number of the IPP standard. This is version 1.1. Then it has an operation ID, which tells the printer, like, what is the client trying to do. In this case, it's operation 11, which means get printer attributes. So the client is asking the printer what capabilities does the printer have. And there is a request ID, which basically means that every time a server responds, it needs to like just have the same request ID as it's responding to, so you can have multiple requests running at the same time. And then comes a lot of what's called attribute groups, and attribute groups are spaced with a delimiter tag, and the delimiter tag 01 is what's called the operation attribute group, and it has like a lot of stuff, which basically is like key value pairs, and some can be like arrays, and they kind of like invented their own system for storing data, which is really weird. And then finally, after you get like a lot of these like data that the client is trying to send to the server, you get an 03 delimiter tag, which basically means end of attributes. No more attributes. We're done. Now actually comes the document we're trying to print, if we're trying to print a document. In this case, we're trying to get the printer's attributes, so there's no document. But if we were trying to print, then the actual document, which is usually PostScript, but actually can't be anything. Will come after this. So I wrote this thing, IPP encoder, which is a encoder-decoder module on NPM that you can use to encode and decode these blobs of data. And around that was pretty simple to write something called IPP printer, which basically just sets up an HTTP server, optionally broadcasts using JSConf on the network, saying, hey, here I am, this is my name, I'm under support. And then just basically takes whatever it gets and pipes it into the encoder and handles the response and makes sure that the response, so when it gets when it gets the get printer attributes, it knows how to respond. Like it could be stuff like, do you support color, or how many trays do you have, or what is the level of your toner, or stuff like that. Which is, and you can send error codes back. Actually, you could like do PC load letter. Oh yeah, let's do that then. Okay. So there's my mouse. Boom. So let's try to print something. Maybe I should actually go out of full screen. There we are. Like this. So if we, basically you can do npm install IPP printer, and you can use it programmatically, so you can require it from your own stuff, or you can, there is like just a command line tool that you can just run. And now it's listening on a port, and it's broadcasting at the same time. So let's open system preferences. Let's go to printers and scanners. Let's add a new printer. And there we have it, IPP printer. I could call it anything, but let's go with this. You can see it's a generic PostScript printer, so it just knows PostScript, which is really nice. I click Add Printer, and yeah, that's fine. Let's do this. Boom, I have a new printer. So let's. I wasn't joking. Let's try to print the slides. Where do we have them? There. So let's try to print the slides. So you can see the printer is chosen here, and let's print. And let's see what's going on here while it's printing. Oh, boop, that was it. Printed, and there was the PS file. A PS is PostScript. So let's close this. Actually, we have that mirroring for this. Okay, where's it? There. Whoa, there we go. Oh, I can just change it. And preview is really neat at understanding PostScript. So there we have my slide. Pretty simple. So now we have a printer. It's written in Node. And you can do a lot of cool stuff with that. I found out. So let's go back here. Oh yeah. No. Actually, I should show you this. This is so cool. So there's something called GhostScript. So I made something else called printcat. There's a lot of opportunity in GIFs for printcat, by the way. So what we want to do is we want to pipe printcat to PS2 PDF, reading from standard in, and writing to job.pdf. So let's do this. Let's run that, and then let's go back and let's add a new printer. Now we have the printcat printer. Let's add this. That's awesome. Cool. Let's go and print the slides again. And the printcat printer, yes, cool. And it will exit when it's got the first print job. Print cat will exit. Boom, there it goes. So now I basically just converted my print job to PDF. Yep, job. Yeah, there we go. Boom. Not as good a result as I would hope. So it's okay. Yes, cool. So there's a lot of cool stuff you can do. And actually, if we just run this again, and then you can specify a debug flag. Let's just do star. And then let's put it into full screen again. Let's clear this. Oops, caps lock. Okay. Just want to show you. So if you try to print something again, let's print this thing. This again. It's going to be printed to the IPT printer. Now you can actually see the traffic that goes on. There's a lot of calls back and forth to figure out what to do. Let's support this. Cool. So all this. Remember the hex, the binary stuff that I showed you before. I basically made a format that is really a little bit easier to understand. So I decoded, and so what you can do is you can also encode it using giving it this. So if you want to make a response to a printing client, you can give JSON values like this. Here, basically, this seems to be a response to it, probably asking like, do you support marker colors? And I write back, no, I don't support it. You can see this is the request it's giving. So this is actually operation 11, the one you saw before. It's saying it's requesting some attributes for the printer, like marker types, marker names, media, column supported, I guess, operation supported, print color mode supported, stuff like that. And I'm responding back with, this is the stuff I don't know, and then I'm responding back with, this is the stuff I know. So I support these operations, and my printer state is currently 3, which is idle. And the reason for being idle is apparently none. That's the stuff you do. And these are all the document formats I support, like PDF, PostScript, plain, stuff like that. Anyways, all good. Let's go back to this stuff now. So what can you do with this? I made a print to Kindle. Like, you can print something and it appears on your Kindle. That's pretty neat. Instead of you having to email it to this like weird email address that Amazon gives you. Or you could like print to your accounting system. So at least in my accounting system, when I need to do my taxes, it would be nice if I have like the PDF of the invoice that or the receipt. So if you just, and most accounting systems have this, or many accounting systems have this feature where you can like import like a scanned version of the stuff you're doing your bookkeeping on. Or I don't know, you could print to tweet. I don't know how that would work. The stuff I'm working on now is NCFAECP, which stands for NSA, CIA, FBI Auto Censoring Printer. Basically, what you do is you print something and it comes out like this. I was also working with the idea that you could probably change words inside your document to be funny one way or the other, or inject ads, maybe, I don't know. So I wrote this thing, print bin, last night. And print bin, this is print bin. Do you guys know Substack made something called HTML bin, and there is similar services out there? This is print bin. And basically, it's a printer on the internet, and everybody can print to it. And the jobs, they basically show up here, and somebody printed. You should be really careful what you click here, by the way, because people can print any sort of stuff. I was looking at this the other day just to be sure. Apparently nobody, I just made it yesterday, so. But this is actually not me who printed this. But apparently somebody on Twitter found it and printed this. I don't know who it was. And you can go here, and you can see the details. Whoa. So basically, all you do, you npm install printbin as a global, and printbin is basically just a proxy. It actually is not a printer. It's not even a proxy. It's wrong to say it's a proxy. All it does is it's just saying, hey, I'm a printer on the network using the Bonjour, the JSConf standard. Oh, and my IP is, and then it just points over there to the internet. And it basically just allows you to have a little daemon running that's basically advertising a printer that's not even on your local network. So let's try to do that. So we basically start printbin, now advertising the printer on your local network. Oh, that's cool. So let's go back here. Let's add a printer. We have printbin. Let's add this. That's cool. Awesome. So now let's try to print this. And you can see we have selected printbin. Put print. And then we go to, where was it there? We go back. And then we reload the page. And wait a little bit. There it was. And we're downloading. PostScript is extremely huge, by the way. It's like a lot of data. Max Ogden, he tried to print the Bible to me just as a joke, because I was advertising a printer on my local network, and he was like, I'm gonna print the Bible. And it was basically just text. There's a lot of pages though, but it was just text. There was no images, no nothing. It was a stripped down version. And the HTML itself was like a few megabytes. The PostScript was 630 megabytes. I was like, it's just text. I don't know. PostScript is a funny format. So, there we go. Yeah, that's it. Final slide.